Welcome to lecture series EPG Padasala for Computer Science. In this lecture, we will be discussing the components of software quality assurance. Learning objectives: explain the schematic overview of software quality assurance architecture, identify the contribution of each software quality assurance component, outline the factors affecting the use of software quality assurance components. Major content of this presentation has been prepared from the textbook Software Quality Assurance from Theory to Implementation, authored by Daniel Gellin, Pearson Education Limited, 2004. The software quality assurance system and SQA architecture. A software quality assurance system combines a wide range of components to challenge the multitude of sources of software errors and to achieve an acceptable level of software quality. Software quality assurance system components can be classified into 6 classes: pre-project quality components, project lifecycle quality components, infrastructure error preventive and improvement components, software quality management components, standardization, certification, and software quality assurance assessment components organizing for software quality assurance, the human components. The software quality assurance system: pre-project software quality assurance components, contract review, project development plan and quality plan, formal design reviews, peer reviews, expert opinion, software testing, software maintenance, software quality assurance of external participants, quality infrastructure components, procedures, supporting devices, training instruction, preventive actions, configuration management, documentation control, quality management, project progress control, software quality metrics, software quality cause, standards, quality management standards, project process standards, organizational base human components, management, software quality assurance unit, software quality assurance trustees, software quality assurance committees, software quality assurance forums. We will be discussing one after the other. Pre-project components. The software quality assurance pre-project components improves the preparatory steps taken prior to initiating work on the project. Contract review, development and quality plans. Contract review activities include clarification of the customer's requirements, review of the project's schedule and resource requirement estimates, evaluation of the professional staff's capacity to carry out the proposed project. We are aware that staffing plays a major role. We have to identify the right person for the right task. Evaluation of the customer's capacity to fulfill his obligations, evaluation of development risks, development and quality plans. The main issues treated in the project development plan are schedules, required manpower and hardware resources, risk evaluations, organizational issues, team members, subcontractors and partnerships, project methodology, development tools, software reuse plans. The main issues treated in the project's quality plan are quality goals expressed in appropriate measurable terms, criteria for starting and ending each project stage, lists of reviews, tests and other scheduled verification and validation activities. Software project lifecycle components. Several software quality assurance components enter the software development project lifecycle at different points. The main components are reviews, expert opinions, software testing, software maintenance, assurance of the quality of the subcontractor's work and the customer's supplied parts. Reviews, formal design reviews. The design phase of the development process produces a variety of documents. The developer continues to the next phase of the development process only on receipt of formal approval of these documents. Ad hoc committees examine the documents presented by the development teams and carry out formal design reviews. Peer reviews. Peer reviews, inspection and walkthroughs are directed at reviewing short documents, chapters or parts of a report or a coded printout of a software module. The main objective of inspections and walkthroughs is to detect as many design and programming faults as possible. Expert opinions. Turning to outside experts may be particularly useful in the following situations: insufficient in-house professional capabilities in a given area. In small organizations, in many cases, it is difficult to find enough suitable candidates to participate in the design review teams. In such situation, outside experts may join a design review committee, or alternatively their expert opinions may replace a design review. In small organizations or in situations characterized by extreme work pressures, an outside expert's opinion can replace an inspection. Temporary inaccessibility of in-house professionals. Waiting will cause substantial delays in the project completion schedule. In case of major disagreement among the organization's senior professionals, an outside expert may support a decision. Software testing. Software tests are formal software quality assurance components that are targeted towards review of the actual running of the software. Software testing programs are constructed from a variety of tests, some manual and some automated. The test report includes a detailed list of the faults detected and recommendations about the performance of partial following a subsequent round of corrections based on the test findings. Software maintenance components. Maintenance services falls into the following categories: 1. Corrective maintenance, 2. Adaptive maintenance, and 3. Functionality improvement maintenance. There are also other types of maintenance. Corrective maintenance: users support services and correction of software code and documentation failures. Adaptive maintenance: adaptation of current software to new circumstances and customers without changing the basic software product. Functionality improvement maintenance, the functional and performance related improvement of existing software carried out with respect to limited issues. The main software quality assurance components employed in the quality assurance of the maintenance system are as follows: pre-maintenance components, maintenance contract review, maintenance plan. Next, software development lifecycle components. These components are applied for functionality improvement and adaptive maintenance tasks. Infrastructure software quality assurance components, maintenance procedures and instructions, supporting quality devices, maintenance staff training, retraining and certification, maintenance preventive and corrective actions, configuration management, control of maintenance documentation and quality records. Managerial control software quality assurance components, maintenance service control, maintenance quality metrics and maintenance quality costs. Assurance of the quality of the external participants' work. The larger the project, the greater the likelihood that external participants will be required, and the larger the proportion of work transmitted to them. The motivation for turning to external participants lies in many number of factors, ranging from the economic to the technical to personal related interests. Special software assurance efforts are required to establish effective controls over the external participants' work. Infrastructure components for error prevention and improvement. The goal is the prevention of software faults, the lowering of software fault rates and improvement of productivity. This class of software quality assurance components includes procedures and work instructions, supporting quality devices, staff training, retraining and certification, preventive and corrective actions, configuration management and documentation control. Procedures and work instructions. Procedures are planned to be generally applicable and to serve the entire organization. Work instructions provide detailed directions for the use of methods that are applied in unique instances and employed by specialized teams. Because they reflect the organization's past experience, constant care should be taken to update those procedures to current technological, organizational and other conditions. Supporting quality devices. One way to combine higher quality with higher efficiency is to use supporting quality devices such as templates and checklists. They contribute to meeting software quality assurance goals by saving the time required to define the structure of the various documents or prepare lists of subjects to be reviewed, contributing to the completeness of the documents and reviews, improving communication between development team and review committee members by standardizing documents. Staff training, instruction and certification. Within the framework of software quality assurance, keeping an organization's human resources knowledgeable and updated at the level required is achieved mainly by training new employees and retraining those employees who have changed assignments. Continuously updating staff with respect to professional developments and the in-house hands-on experience required. Certifying employees after their knowledge and ability have been demonstrated. As an example, consider a team is working on a project which uses an Oracle database management system and forms, the project is complete and is deployed. Currently, the next requirement is to develop a project using PHP and MySQL database management system. The staff who are already working in a project which used Oracle database management system and Oracle forms have been assigned to the new project which involves PHP and MySQL database management system. Appropriate training has to be given to the staff in PHP and MySQL so that they are able to develop and deploy a quality assured software product. Preventive and corrective actions. Preventive and corrective actions include implementation of changes that prevent similar failures in future, correction of similar faults found in other projects, and among the activities performed by other teams. Implementing proven successful methodologies to enhance the probability of repeat successes. Configuration management. The regular software development and maintenance operations involve activities that creates new version of the software. Different team members carry out these activities simultaneously. As a result, serious dangers arise, whether of misidentification of the versions or releases, loss of the records delineating the changes implemented, or loss of documentation. Configuration management deals with these hazards by introducing procedures to control the change process of documentation. Documentation control. Documentation control functions refer mainly to customer requirement documents, contract documents, design reports, project plans, development standards. Documentation control activities include definition of the types of control documents needed, specification of the formats, documentation identification methods, definition of review and approval process for each controlled document, definition of the archive storage methods. Management software quality assurance components. Managerial software quality assurance components support the managerial control of software development projects and maintenance services. Control components include project progress control, including maintenance contract control, software quality metrics, software quality costs. Project progress control. The objective of project progress control components is to detect the appearance of any situation that induce deviations from the project plans and maintenance service performance. Project control activities focuses on resource usage, schedules, risk management activities, budget. Software quality metrics. Among the software quality metrics available or still in the process of development, we can list metrics for quality of software development and maintenance activities. Development teams productivity, help desk and maintenance teams productivity, software false density, schedule deviations. As I have mentioned, each phase of the software development life cycle involves effort, and a schedule has to be followed. Delay in a particular phase may delay the other phases also. For example, if your software requirement specification document is not prepared in time, the design phase may be delayed. When there is a delay in the design phase, the coding phase may get delayed. If the coding is delayed, testing will be delayed, and ultimately you cannot deliver the product in time. The quality costs incurred by software development and application are according to the extended quality cost model. With respect to the specific software quality assurance strategy applied, analysis of software quality costs can direct software quality assurance efforts to the improvement of activities that cause significant failures. Software quality assurance standards, system certification and assessment components. External tools offer another avenue for achieving the goals of software quality assurance. The main objectives of this class of components are utilization of international professional knowledge, improvement of coordination with other organizations' quality systems, objective professional evaluation and measurement of the achievements of the organization's quality systems. The standards available may be classified into two main subclasses: quality management standard, project management standards. Quality management standards. These standards focus on what is required and leave the decision about how to achieve it to the organization. The most familiar examples of this type are SCI CMM assessment standard, ISO 9001 and ISO 9003 standards. Project process standards. Project process standards are professional standards that provide methodological guidelines dealing with the question of how for the development team. Well known examples of this type of standards are IEEE 1012 standard, ISO IEC 12207 standard. Organizing for software quality assurance, the human components. Software quality assurance components require an organizational base. This base includes the organization's management, software testing personnel, software quality assurance units, professionals and other practitioners interested in software quality. The main objectives of the software quality assurance organizational base are to develop and support implementation of software quality assurance components, to detect deviations from software quality assurance procedures and methodology, to suggest improvements to software quality assurance components. Organizing for software quality assurance, the human components, management's role in software quality assurance, definition of the quality policy, effective follow-up of quality policy implementation, allocation of sufficient resources to implement quality policy, assignment of adequate staff, follow-up of compliance of quality assurance procedures, solutions of schedule, budget and customer relation difficulties. The software quality assurance unit's role: preparation of annual quality programs, consultation with in-house staff and outside experts on software quality issues, conduct of internal quality assurance audits, leadership of quality assurance various committees, support of existing quality assurance infrastructure components and their updates and development of new components. Organizing for software quality assurance, the human components continued. Software quality assurance trustees, committees and forums. Software quality assurance trustees are members of development and maintenance teams who have a special interest in software quality and are prepared to devote part of their time to these issues. Their contributions include solving team or unit local quality problems, detecting deviations from quality procedures and instructions, initiating improvements in software quality assurance components, reporting to the software quality assurance unit about quality issues in their team or unit. Factors affecting the use of software quality assurance components. Organizational consideration, types of software development client, types of software maintenance client, range of software products, size of organization, degree and nature of cooperation with the organizations carrying out related projects, optimization objectives. Project and maintenance service considerations, level of complexity and difficulty, degrees of experience with the project technology, extent of software reuse in the new projects. Professional staff considerations, professional qualifications, level of acquaintance with team members. I acknowledge the authors of the books which I have referred and the web resources I have used for this presentation. Thank you.